Alright, hello. So in a previous video we talked about solving systems of linear equations using the substitution method. In this video we're going to be talking about but now using what we call the elimination method. Elimination method works best when it's in standard form, ax plus by equals c, so always make sure you rewrite it into that form to work it out. And this will work by either adding or subtracting the two equations from each other. Elimination because it's going to cancel one of the variables. The remaining variables then, whatever cancels, it's gone. Like if y cancels, you're left with x. Solve for x, plug it back in to get to y. So that's the advantage of it. So we ideally want to try and add or subtract the two equations. And addition works is if you'll notice that one of the variables has the exact same coefficient number in front of them, but opposite signs. So you have like a positive 2x and a negative 2x. Negative 6y, positive 6y. Something like that is where you can use the elimination method by addition. So for this equation right here, we have, that should be a 3x, not 32. My apologies. So we have 4x plus 6y equals 32, and then we have 3x minus 6y equals positive 3. So if we know what's in front of the y is the same number in opposite signs, this means we just simply add the equations together. 4x plus 3x is 7x. 32 plus 3 is 35. So when we divide by 7, x is just simply 5. Where now we plug it back in, doesn't matter where. If we do the top equation, 4 times 5 plus 6y equals 32. 20 plus 6y. We subtract the 20 and divide by the 6 to get y equals 2. If you plugged into the bottom equation, it would still give you a positive 2 for your answer. So ultimately, it doesn't really matter which one you plug into. But again, the key is recognizing same number, opposite signs, add the equations together. Something like this. Negative 4a plus 3b equals negative 3. 4a minus 5b equals 5. We take a look at the a's. There's the same number in front, and one negative is one positive. So again, we just add the equations together. A's cancel. 3 plus negative 5 is negative 2b. Negative 3 plus 5 is positive 2, so b is negative 1. And then we plug that answer back into either equation, doesn't matter. I'll plug it into the bottom equation this time just to be a little different. So we'll have 4a minus 5 times negative 1 equals 5. So the negatives will cancel, making it 4a plus 5 equals 5. When we subtract 5, we get 4a equals 0. So we divide by 4, a equals 0. And again, that's okay. We're allowed to have 0 for an answer. It's just if the variable had happened to cancel out, then we would have no answers then. Alright, so again, same number, opposite signs, add them together. When they're the same number and the same sign, you have two options. You can think of it as subtraction at that point, because you can cancel numbers by subtracting if they're the same sign, or, I generally find this to be a little bit better for most students, multiply one of the equations by a negative 1, which will then give you still the same number but now opposite signs, and then you add them together. For the most part, at least in my experience, it seems that students make less mistakes with the negative aspect of the systems of equations if you're adding them. When you subtract them, it seems to mess people up. So I'm going to use the option 2 right here when I work through it. If you're comfortable subtracting, that's fine. Just make sure you're careful with your final answers. So we have 3v plus 7w equals 31, 3v plus 4w equals 10. So what I'm going to do is I'm going to just simply rewrite the first equation, 3v plus 7w equals 31, and I'm going to multiply the bottom equation by negative 1. So it'll be negative 3v minus 4w equals negative 10. So when we add them together, the v's will cancel, and we get 3w equals 21, so therefore w is 7. And if we take that 7 and plug back into either equation, we'll just assume the top one. We get 3v plus 7 times 7 equals 31. So 3v plus 49 equals 31. 3v equals negative 18. So v is negative 6. If you want to work out a problem like this, just simply by subtracting from the beginning, you'll find by subtracting, v's cancel, 3w equals 21. It's ultimately the same answer. So when they're positive signs, it's really not a big deal to just kind of subtract. There's no negatives. It gets a little more interesting when you have negative signs involved here, which is why it's useful for most students to multiply one of the equations by a negative number. So again, we'll leave the top equation alone, so it'll be 6f minus 3g equals negative 15. But then the bottom equation will become negative 8f plus 3g equals positive 23. Again, I'm not 100% sure why. There's just a lot of confusion with the negative signs there. As long as you're careful, it doesn't matter. But I guess it's just easier to visualize a negative sign and a positive sign when you're adding versus double negatives and subtracting. So that's why it's handy. Either way, we add. G's cancel, leaving us negative 2f equals a positive 8. So therefore f is negative 4. Once we have f, again, plug it back in. We'll plug into the bottom equation. 8 times negative 4 minus 3g equals negative 23. So negative 32 minus 3g equals negative 23. We add the 32 over to get negative 3g equals positive 9. So therefore g is negative 3. Like I said, it doesn't matter whether you just think of it as subtraction as long as you're careful, or if you just multiply one equation by a negative number to get rid of your negative signs. Both are perfectly acceptable. Okay? Now, these are easy because the number in front of the variable is the exact same already. That's not how most of the equations work. Multiplication with eliminations when you notice that all the variables have different numbers in front. So all we need to do is simply just find two numbers that have a common multiple, preferably one where you only have to multiply one equation in the problem by to get to that number, and trying to find the least common multiple in that case as well. Once we do that, we now have the same number, and now we either add or subtract, whichever one we are more comfortable with. So if you notice, with this equation right here, we have 3x minus 2y equals 13, and 2x plus y equals 4. We could eliminate the x's, but 3 and 2, their common multiple would be a 6. So we have to multiply the top equation by 2 and the bottom equation by 3. Whereas the y's have a 2 and a 1, so their common multiple is a 2. So we only need to multiply the bottom equation by 2. Sometimes you will have no choice but to multiply both equations. Obviously, to make less of a possibility of making a mistake, you're better off multiplying only one equation. So top equation stays the same, 3x minus 2y equals 13. But now the bottom equation we multiply by 2. So it became 4x plus 2y equals 8. Now at this point we apply the same methods we saw in the previous examples. The number in front of the y's are both the same now, and they're opposite signs. So that tells us to add the two equations together. Getting 7x equals 21, so x equals 3. As far as plugging back in, we can plug back into the altered equation or the original equations. Since this problem has a y with no coefficient in front, I would say it's probably best to plug into that original equation. 2 times 3 plus y equals 4. There's just simply one less step you have to worry about. Again, it doesn't matter. In either equation, you're going to get negative 2 for y. So you could have plugged it back into the original top equation or into the altered bottom equation. Both will give you negative 2, as long as you don't, break math in the process. Okay, so for something like this, we have 5c plus 4d equals 6, 3c plus 2d equals 4. So if you look at c's, 5 and 3, a common multiple is 15. So we have to multiply both equations. But if you look at the d's, 4d and 2d, the common multiple would just be 4 then. So we only have to multiply the bottom equation. Now, again, I prefer trying to add them together. We notice they're both positives, so if I multiply by a negative 2 to make the d4, they'll be opposite signs. So we get 5c plus 4d equal to 6, negative 6c minus 4d equal to negative 8. So now the d's have the same number opposite signs, so the equations add. You get negative c equals negative 2, so c is a positive 2. Where that now plugs into either equation, plug into the top. 5 times 2 plus 4d equals 6. And when we solve this out, we're going to get a negative 1 for d. Alright, so that's the idea behind the elimination method. I do want to show you at least one more example. Yeah, this is a good one. So what we have right here is we have 4p minus 12r equals negative 20, 2p minus 6r equals negative 46. So 4p and 2p, common multiples of 4. 12r, 6r, common multiples of 12. So in both equations, we need just to multiply by a negative 2 to get to be the same number and opposite signs. Well, if you notice in this case right here, we're going to get 4p minus 12r equals negative 20. And the negative 4p plus 12r equal to a positive 92. When we add the equations together, not only do the p's cancel because the 4's are the same number as opposite signs, but so do the 12r's. So the left side is just 0. The right side, though, does not cancel. Negative 20 plus 92 is a positive 72. As we talk about the substitution method, and as we talked about their basic linear equations, we cancel the variables, false statements, no solution. Can't solve the problem. Whereas something like this, when we multiply the bottom equation by a 3, because if you'll notice, 3 times 3 is the 9, 4 times 3 is the 12, so we can cancel the variables there. We're going to have a similar setup. 9x minus 12y equals 36. Negative 9x plus 12y equals negative 36. Now when we add to cancel the x's, the 9x's cancel, 12y's cancel leaving 0, and the 36 cancels. Variables cancel when it's true statements. This is the all real numbers, or infinite solutions. Okay, so you just got to watch out for whichever method it ends up happening to be. Like I said, ideally you try and only multiply one equation if you can. There'll be sometimes you might have to multiply both equations, and that's just fine. Just make sure you're careful with that. And then, as always, if the variables happen to cancel, look for whether it's a true or false statement. Again, true meaning it's infinite solutions, all real numbers. False statement means it's no solution. Okay, so that's it for systems of equations. So I'll see you next time with the next video.